now you're seeing my screen. It says determine whether the two triangles are similar. Okay, so for clarity here, it's this triangle CDE,
Mhm.
and then the big triangle
Is
CAB.
CAB.
Now, do you see that they share an angle?
Yes.
Okay. Now, the next thing we have to figure out, see, this is 14, and we don't know, oh, wait, and that's 12. What is the whole length here? It's 14 plus
3.5, so that's 17.5.
Right. And then they give you this. Okay. So the question is 14 over 17.5 equal to 12 over 15? This side, 14 and 17.5, they have to be proportionally the same. Same with 12 and 15. Okay. So one way to do this is actually just to get your calculator out and divide. I don't really like that, but you could definitely do that if you wanted.
Okay.
The other way is to actually cross multiply here and see if they give you the same value, which, maybe you still need to use your calculator, maybe you don't. So can you tell me that?
0.8.
Oh, that doesn't mean anything to me. What do you mean by that?
Oh,
point
so
8?
sorry. Oh, I divided 14 and 17.5 and I get 0.8. Sorry.
Okay. What about 12 over 15?
Also the same thing, 0.8.
Okay. So they are similar. They are
Yes.
similar. Okay. So they're similar because the angles are the similar.
Mhm.
Okay. And then you got these sides that are in proportion. And you got another angle up here. Let me go 2 of those. You got that angle and then that angle. So they're actually similar by angle side, or side angle, or side. Okay, so the next one I don't like. Okay, let's do this one. I don't like this one. Let's do this one. Trying to do it in an order where maybe there's some learning that can happen here. Okay, so the next question here, it says determine whether the two triangles are similar. So there's this smaller one, OPN, and then there's this bigger one, OLM. Can you give me this long side length here?
13.5.
Okay, and how about this other one?
9.
Okay, so again, it's ratios. Is 3 over 13.5? See this one and this one? Is that equal to 2 over 9? So can you tell me yes or no to that?
Okay, hold on. Yes, they are the same.
They're the same. So they share a side. And do you say they both share this angle?
Yes.
So side, angle, and then side. All right, next question here. And then and then it moves into some exceptions, but we'll look at those next. So, okay, determine whether the two triangles are similar. So like they're not really oriented correctly. So let me just redraw them here. PRQ, that's 62 degrees. Then here's the other one here, because you want to have them in the same orientation. Do you know what I mean by that, by same orientation?
Yes.
Okay. So this is a right angle and this is a right angle, and this is 62 and this is 62. From previous classes that we've done, like what do the three angles in a triangle have to add up to?
180.
180. Okay. So that means that this is 28 degrees and this is 28 degrees. So do you see that all the angles are the same in
Yes.
these triangles? So because it's a right triangle, you actually only need one of the angles, one of the non-right angles to be the same, because the other one is guaranteed to be the same. Because like if we knew that this was 28 and this was 28, then you could calculate the other one. So that's why you only need one of the angles.
I see.
Okay, so let's do another one of these here. I need just a moment, please.
Okay.
All right. So let me snip this question in. So again, there's two triangles here, and like one of the challenges with this class is you got to be able to separate the two triangles. This is CDE
Mhm.
and an 8. And then this is CAB 9.6. What's the length down here?
The length is 10.
The
Oh,
whole
10 plus 2 is 12.
12. So now again, it's ratios. Like it's this side to this side is 10 over 12 equal to 8 over 9.6.
Yes, they are the same.
They're the same. Okay, so these are similar. And they're similar to this. See how they share an angle? Christopher?
Oh, sorry.
Do
Can
you
you
see how
repeat that?
do you see how they share the angle? This angle is the same for
Yes.
both.
Yes.
And then you got a side and another side.
Yeah. Yeah. Sorry. Can you give me 1 second, please?
Yes,
Thank
yes.
you. Sorry about that.
Okay, everything okay?
Yeah. Please continue.
All right. Okay, now it says in this problem, it says, given that the two triangles are similar. So like we know that they're similar. Okay. And one of the things I think is frustrating here is like they actually don't tell you like the orientation here. So I'm just going to make a guess here that this is GIH, okay, like it's given, and then it's R. Like I see this as QPR.
Yeah, that's what I see as well.
Okay, so we got to match letters up. Like H has to go with R. So see
Hmm.
how H goes with R there? That's a good start.
Yeah.
And then I has to go with P. I has to go with P. That's looking pretty good.
And G has to go with Q.
Right. So we're looking for one that's incorrect. So that one's
Oh,
good.
incorrect.
So that one's out. So now does I go with P? I goes with P.
Hmm.
The next one. H goes with Q. That's
Does
wrong.
not. Yeah. So
So
that's incorrect.
that's incorrect. Good. It's a little bit of test prep there on that one. So we got one more question here. It's actually a lot like the one that we just did with the 90-degree triangles, but it's not a 90-degree triangle. So it's, so let me get this in here to give you some context.
Okay.
Okay, so like here, 21 is the same as 21. So that means you've got an angle that's the same.
Yes.
We don't know K, we don't know R, but we know that they're the same. So that gives you
Yes.
another angle. So AA is enough for similarity
Okay.
because they have the two of the same angles. Because like let's just say that this is like 79 degrees and that's
Hmm.
79 degrees. Well, then the third angle has to be the same
Yes.
because they have to add up to 180. All right, so I'm going to submit that and we'll move on to what we started with last time. Whoa, interesting.
Is there something wrong?
Yeah, I didn't even, I guess I wasn't paying attention to a couple things here, but let me just look at these. What was the issue? Oh, I see. Okay. Everything I said was we can go with everything I said. I'll just be a little bit more careful here on the quiz
Okay.
with a couple of things because I'm now seeing some stuff here. Okay, so let's go next. And let's resume this thing. Okay. Okay, so we actually got, we snip in this question here. Okay, given that the two triangles are similar, and again, like I have to redraw them, and that's one of the things I like about this digital format is that we can quickly, redraw these things. So there's T, there's U, and there's S. So again, we're looking for the one that's incorrect.
Mhm.
Okay, so let's look at the first one. L has to go with T. Does L go with T? Yes.
Mhm.
N has to go with U, and M has to go with S. So that one's out. Here, N goes with U. Is that right? Does N go with U?
Yes.
Okay. Does M go with S?
Yes.
Okay, so that one's out. Next one is M goes with S. That's true. L goes with T. That's true. And N goes with U. So that's true. So all of these are correct, it looks like.
Yeah.
Is that clear how we did that?
Yes.
Okay. All right. Interestingly, they moved to proofs for the next couple here, which we didn't see any on your homework at all. Let me see. Okay, let's go to the next one here. Determine whether the polygons are similar. If so, identify the similarity ratio and similarity statement. So which side does 5 go with?
12.
5 goes with 12. Which side does 12 go with?
12 goes with 18.
And what about the 13?
Goes with 20.
All right, so you tell me, are those the same? And you're welcome to use a calculator if you need to.
5. No, they're not.
They are not. Good. All right, so okay, so let's do another one here. Some of them were repeats from the quiz, or I'm sorry, some of them were repeats from the
Lessons.
lesson we just did. So no reason to redo those. Okay, identify the correct explanation for why triangle ABC, okay, and that's this one up top here, and DEC are similar. And then they want you to find EC. Okay. So do you see that this angle is the same as this angle?
Yes.
That's vertical angles. This side is congruent to this side.
Mhm.
Does that make sense?
Yes.
This angle is congruent to this angle down here.
Mhm.
Okay, and that's by two lines. When two lines are parallel and they're cut by a transversal alternate interior angles, you remember that?
Yes.
Okay, now if we go the other way, this angle is congruent to this angle down here, and that's this one and this one. So basically all three angles are congruent.
Yes.
And that's AA. That allows you to prove congruence by AA. So we want E to C, right?
Mhm.
Which
Yes.
means that well, okay.
That's half
So
of
18 to
E to
20,
B.
yeah, well, no, 18 to 24 equals 24 over X.
Oh,
So this one goes with this one down here. So do you remember that we can cancel out horizontally? I'm sorry, vertically.
yeah.
So what goes into 18?
6.
Okay, so that becomes 3/4 equals 24 over X. Now this is interesting, and a lot of people don't realize this. You can actually cancel out this way. What number goes into both 3 and 24?
8. Well, 3
3,
actually.
and that gets that to 8. So notice we've really can't made this proportion a lot nicer. So now we can cross multiply here.
Mhm.
1x equals 4 times 8. X
32.
equals 32. Very good. Okay, so I'm looking at, yeah, let me see which one. Yeah, by that. Okay, got that one down. Okay, so then next one here is kind of another oddity. It's like a proof. We didn't see any of those in the lesson. We didn't skip any lessons, did we?
Not that I know of.
Okay, given ABCD is a rectangle, which of the following proves that triangle EAD, so this one on the left, equals EBC, this one on the right? Okay, so now what do you know about a rectangle? Can you tell me anything you remember about a rectangle?
All the sides are congruent.
No, that's a square.
Oh, they have
9-degree angle. So that's a 90-degree angle, and that's a 90-degree angle. What do you know about the sides, the opposite sides?
they're parallel.
Yes, that's true. What else about them?
They're
What does these symbols mean that I've been drawing?
I they're side.
It's a side, but what do you know about these sides over here on the left and the right,
Oh,
and the top and the bottom?
I don't remember.
Well, you do. Like, tell me in words. I mean,
Uh, they have the same. They don't all have the same sides. There's
no,
yeah,
but the ones across from each other, what are they?
they're also sides.
Yes, but like okay, well, here's also is that a rectangle?
No, that's not
Why?
because it's for one. It doesn't even really look like a rectangle.
I know.
Because
So I'm asking you, what is it that makes it look like a rectangle?
it's rectangular.
You can't use the word to describe to define something. Okay. If this is 4, then what is this side over here?
4
Why?
because it's the same number.
That's what I was asking you to say. Because they're congruent. Okay. So is that clear?
Yes.
All right. So basically you've got a side, an angle, and a side, an angle, and a side.
Yes.
All right. Looks like this is good. So we're gonna do this, and then we're gonna move on to some new stuff. Wow, it really didn't like. Okay, so let's go on to the next lesson. And this is your Friday lesson.
All right.
So let's see if we can work through all of this to get you caught up for the week. Oh my goodness, why do they keep doing this? These proofs they're just horrible. Yeah, so let's do this one at a time here. All right, so identify the length of B to A. So it's this whole length here. Do you see that?
Yeah.
So there's 2 triangles. There's this one here, 3.2 ADE. There's that triangle there. And then there's this big triangle here,
Yes.
ABC. So what's the whole length over here?
7.2.
7.2. And if I call this X, which we'll put there, what is this whole length here?
7x.
No, you're not multiplying them.
Oh.
How did you get 7.2?
I added so 7 plus x.
Very good. Okay, so now we can write X over 7 plus X equals 3.2 over 7.2.
Okay.
Okay, now to solve this, we diagonally multiply our butterfly here. So 7.2x equals 3.2 times 7 plus x. 7.2x equals, and then this is 22.4 plus 3.2x. Subtract 3.2x from both sides.
We get 4x
4x equals 22.4.
Then we
So
just divide it by 4.
So x equals like 5.6 maybe. Now, is that what they wanted? Did they want x or did they want the whole thing?
They wanted the whole thing.
So you got to take that 5.6 and add 7 to it to get.
That'd be 12.6.
Very good. So a little bit more work there. Would you agree?
Yes.
All right. This next one is actually a bit easier because you just have to find x.
Okay.
And you said you got some pencil and paper out there on.
Yes.
So this is x.
Mhm.
I'd like you to try this one on your own, please.
Okay.
This is what you should have written for your kind of your setup here with the triangles.
Oh.
So let me know if you got something different than that.
Nope. It's I accidentally added 9.6 and 8.8 together instead of just doing 8.8 plus 9.6 instead of just. But I fixed it now. So
Okay, go ahead and try solving this on your own and seeing if you can come up with the right answer. Okay.
okay.
Take a minute or two if you need. How are you doing on this one?
I'm almost done. Okay. I get something different for 8.8.
Okay, what do you get? Because I'm not paying that much attention to this. I need to grab
So
my calculator as well.
so 8.8 times 6 equals 52.8. That's what I get.
Yes, that's right. 52.8. Okay. And you got 18.4x over here.
Mm-hmm.
Okay,
So
so
then,
you subtract.
yep. I have the answer, but I just want to make sure that
What's your answer?
5.5.
Okay, I agree.
Okay.
Excellent. Excellent. Okay. Yeah, so this is a similar problem again. They've really made these difficult by choosing decimals. So a lot of times textbooks will choose whole numbers to make this go a bit nicer. So here we're going to call this x, over here, which is not that X, it's variable X.
Yeah.
So the whole thing, this is how I used to draw it when I was your age, is I would write X plus 4.
Mhm.
And then I would also identify the whole length here, which is 5.5.
Mhm.
So it's triangle to triangle. It's not like this to this. So it's 2.5 over 5.5 equals 4 over X plus 4.
Okay.
Okay, so now again, we're just going to diagonally multiply and solve for X. So can you do that for me, please? And let me know when you get the right answer.
Sure.
Excellent.
Okay. I get 4.8 for X.
Okay, so now the question is it asking for X or does it ask for the whole thing?
It's asking for the whole thing.
So what is the whole thing?
Whole thing would be 8.8.
Very good. All right, so you're doing a great job here. So one more of these. They're actually all the same. I realize they're the triangle to triangle. So the first one, which is kind of a proof, is just we'll look at last. It's not really a proof. It's just a calculation here. So let's call this X.
Mhm.
This whole length is X plus 7. This whole length is 40.
Okay.
So it's X over, it's the small triangle to the big triangle, X plus 7 equals small triangle 28 over 40.
All right.
So this time when you diagonally multiply, you get 40X equals 28 times X plus 7.
Mhm.
That's 28X. So to multiply by 28, 7 times 20 is 140. 7 times 8 is 56. So that's 206. That's a little shortcut there for that. Subtract 28X, divide both sides by 12, and X equals, so like 206 is really, I don't know, 144. Actually, it's 156 plus.
You get 17.16.
So it doesn't work out exactly.
It doesn't look like it works out. Yeah,
Interesting.
17.16666, etc. So
Really? Did
it,
we make a mistake here?
so that's 30 and then 40. So X
Is 20, check
7.
28 times 7. Maybe that's the mistake. It is. It's 196.
Yeah.
There it is. So that's 196 divided by 12. What's your new answer for that?
96. I get, sorry, 16.3.
3 repeating?
Yeah.
Good. Okay, great. So I think we're up to the last one here. And there's no variables this time. It's just verifying the ratios that we've been doing. So you'll
Mhm.
notice here in this picture. So you got, again, like we really want the whole length here,
Yeah.
20, and we really want the whole length here, which is 12. So is 4.5 over 12, the smaller triangle to the bigger one, equal to 7.5 over 20? Are those the same? And I'm asking you.
Let me check. Yes, they are.
They are. So this is definitely true, right?
Mhm.
Okay, so they do it slightly differently, but let me see if I can find this. Every one of these has a mistake in it. What is what is 7.5 over 20 become?
0.375.
Okay, so I think we got it here. Just checking to see. Oh, I did skip one here. So we got one more and then we're done with this lesson. And you're all
Right.
caught up for the week. So it looks like we might actually need 2 lessons a week to kind of get through this stuff. Okay, identify the lengths AB. There's AB and AC. Interestingly. Okay, so the triangles again, like what I find really hard here is that you gotta separate the 2 triangles here.
Yeah.
And what probably isn't clear. So this is x plus 7. This is x minus 7. This is 8, and this is 20. So I believe that it's actually these 2 sides go together. So it's going to be x minus 7 over x plus 7 equals 8 over 20.
Okay.
So let's just try working that out together. So that's 20x minus 140 equals 8x plus 56.
Mhm.
12x equals 196. So x equals 16 1/3, which is what we calculated
Wait,
before.
196? You mean because that's a negative 140?
But you're adding it to both sides.
Oh, okay. I was thinking of something else.
But that doesn't actually seem to work. So there's something else going on here. I guess in full disclosure, this is probably my weakest. Let's try 8 over 12 equals x minus 7 over x plus 7. So it's 8x plus 56 equals 12x minus 84. So if we add 84 to both sides, we get 140 equals 4x. So x equals 35. And that does work. So we got 30, since we're trying to find the 2 side lengths, it's 35 minus 7, 35 plus 7.
Mhm.
So AB is 28 and AC is 42. Do you see that?
Yes.
All right. All right. Well done. So the next thing, which we won't tackle today, is proportional relationships. So something for Monday. So again, thanks for scheduling. I'll send you the notes and the screen recording out shortly, and I'll see you next time.
Okay. All right. Bye.